Hi all. In continuation with this previous video in which we got introduced to the replacement models, this video is going to help us solve a very elementary problem on replacement of capital items. A problem in which time value of money is not considered, but we would get into a basic way of solving the question. Now have a look at the screen here. This talks of replacement of items that deteriorate with time, capital items, but we are not going to consider the time value of money. Now I would suggest that you take a screen snapshot of the screen where you have the problem, and you could save it in your Word document or whatever, and then probably copy down the problem onto your notebooks at your own time. Now this being the problem that we have, wherein the capital cost of the machine is 10,000 rupees, the operating cost or the running cost and the resale values of the problem or the machine are given here. Now we need to go into solving the problem. Now to solve the problem, we will have a small table that we would create with these headings. Now have a look at these headings here. Don't look at the numbers, just forget the numbers, or rather what I would do is I would try to eliminate these numbers, so it's easy for you to have a look at only the blank table, and then I will tell you how those numbers need to be filled. Okay, so I'll leave here. Now this is the table that we would create. Find that we have 7 columns in all. The first one is year, the second one is the operating cost, which of course we have from the data table itself, the year and the operating costs. So these have just been entered into the table. I think there's a small error in the operating cost. No, yeah, it's all right. I think we have 8 years in all. I should have removed till the 8th year, but I guess I missed the 8th year, so I removed that also here. Okay. If you have a look at this, whatever data we had here is what we have filled here, and the columns are going to be year, operating cost, cumulative operating cost. That would be the summation of the operating cost every year with respect to the previous year. For example, here I would write 1000, then here it would be 1000 plus 1200, that would be 2200, 2200 plus 1400, that would make it 3600, then 3600 plus 1700, and so on. Now the scrap value is again the data that we have here, or the resale value and the scrap value mean one and the same. So we enter the scrap value here, and then the fifth column is the capital cost, 10,000 rupees, minus the scrap value, that is column 4. And the sixth column would be the total cost, which is column 5 plus column 3. Column 5 is the capital cost minus scrap value, and column 3 is cumulative operating cost. And then the average cost here is column 6 divided by column 1, the total cost divided by column 1. So I guess you could listen to this video a little more slowly. Maybe you can pause at each phase, create this empty table, and start preparing your answers in each of these columns. So what I would do is I would just undo the values that I had removed, so you will have these column values filled in here. Okay, so you will see here the operating cost and the cumulative operating costs, 1000 plus 1200, 2200 plus 1400, and so on. This is what I had already spoken to you about. Scrap values again from our data. Capital cost was 10,000 rupees minus the scrap value, 10,000 rupees minus the scrap value, 10,000 rupees minus the scrap value, and so on. Now because the scrap value is coming down, obviously the capital cost minus scrap value would go up. And then the total cost is column 6 plus column 3. So which is, sorry, the total cost column 6 is column 5 plus column 3. And you have the values here: 4,000 plus 1,000, 6,000 plus 2,200, 6,800 plus 3,600, and so on. Now with this we have got the total cost values, and then we calculate the average costs. The average costs are the total cost divided by the year. Now this is 5,000 by 1, 8,200 by 2, 10,400 by 3, 12,700 by 4, and so on. Now if you keep looking at the average cost values, they are constantly coming down till the 6th year, and from the 7th year onwards the average cost begins to increase. So this is the time we should consider replacing the machine. Till the 6th year the average cost is coming down, and from the 7th year it's beginning to go up, and therefore we take a decision that we would replace the machine at the end of the 6th year. At the end of the 6th year. So here we just had a method of calculating the average cost, and then we took a decision on when to replace a machine when the average cost was the lowest, and beyond that it was beginning to increase. So this is a simple replacement model for capital items in which we did not consider time value for money, neither were the depreciation considered here in this problem. In our next video we'll look into a slightly more complicated problem which would lead us to the next level. So bye bye, happy computing now.